I am ready.
3, 2, 1.
What's up mga ka-Triobots? Welcome sa our YouTube channel. My name is Chen Espinoza.
My name is Nica Paula G.
And I am Ronaldo Vitan Jr.
We are from 7-Eleven Prudence.
In this video, we'll be sharing what we've learned from lesson 1 to 3.
For lesson 1, we have the LED. For lesson 2, we have the buzzer. While for lesson 3, we have the 7 segment.
Alright, let's begin.
In lesson 1, we learned all about LEDs. We explored how to make them blink, fade, alternate lights, and even respond to button and potentiometers. Through this lesson, we discovered how to use digital and analog outputs and how a few lines of code can control lights in different ways. For lesson 2, we focused on buzzers, the components that create sound. We made a buzzer beep when a button was pressed and even played a custom melodies by changing tone frequencies. This helped us understand how Arduino produces different sounds and rhythms through simple code adjustments. In lesson 3, we use a 7-segment display to show numeric outputs. We learn how each segment works and how to display digits from 0 to 9. This helped us to understand how to control multiple outputs at once and display data in a simple digital format. After finishing the lessons 1 to 3, we applied what we learned by creating extra projects that combine lights, sound, and logic, showing how Arduino can be used in real-life situations. Task 1. Dancing lights. We made LEDs blink and fade in rhythm. Task 2. Traffic light simulation. We built a simple traffic light system with red, yellow, and green LEDs. Task 3. Custom melody challenge. We program our own short tune using a buzzer. For the task 4, it is a multi-message Morse code transmitter. We sent different messages using button and buzzer. We challenged ourselves to create our own task. We called it the Buzz Lock 5. The sound of the buzzer lasts for 5 seconds.
Alright, now let's take a look at each lesson. Turn out. I show you the circuits and how they work.
For lesson 1, we focused on learning how to control LED lights using the Arduino. Activity 1. Blinking an LED. In this activity, we made a single LED blink repeatedly using basic Arduino code. Activity 2. Fading LED. We tried the fading LED by using analog output. The LED smoothly fades in and out. Activity 3. Alternating blinking LED. It means two LEDs take turns blinking. When one is on, the other is off. The Arduino controls this by turning each LED on and off in sequence using delays. Activity 4. A button-controlled LED lights up when you press the button and turns off when you release it. The Arduino reads the button signals to control the LED's on and off state. Activity 5. An LED brightness control using a potentiometer lets you adjust how bright the LED is. The Arduino reads the potentiometer's value and changes the LED's brightness using PWM or pulse width modulation. Before we finish, here are the challenges we faced during the activities and what we learned from them. One of the challenges we faced in this lesson was incorrect wiring. Sometimes the LED wouldn't light up. We also had to adjust the resistor and check the pin connection carefully. But after troubleshooting, everything worked perfectly. Lesson 2. Buzzers. In this lesson, we learn how to use a buzzer in different ways to produce sound using the Arduino. Activity 1. Buzzer beep on button press. When you press the button, the Arduino sends a signal to turn the buzzer on, and it turns off when we release the button. Activity 2. Melody player with a buzzer. The Arduino plays a series of tones on the buzzer to create a melody. This demonstrates how changing the frequency and duration of the buzzer produces different musical notes. Activity 3. SOS Morse code with the buzzer. The buzzer turns on and off in short and long intervals to spell out SOS in Morse code. Activity 4. Light-sensitive buzzer alarm. A light sensor detects changes in brightness, and the Arduino activates the buzzer when a certain light level is reached. This shows how sensors can trigger outputs to create simple alarm systems. Activity 5. Buzzer sound controlled by potentiometer. The Arduino reads the value from a potentiometer and adjusts the buzzer sounds accordingly. During this lesson, we faced challenges like making the buzzer respond correctly to button, light sensor, and potentiometer. This taught us how to connect components properly, use the correct code, and understand how buzzer can be controlled in different ways. Lesson 3. 7-segment display. It teaches us how to use a 7-segment display to show numbers using an Arduino. Activity 1. We display the number 3 on a 7-segment display. The Arduino turns on the specific segments needed to form the number 3 on the display. This shows how each segment can be controlled individually to create different digits. Activity 2. Displaying numbers 0 to 9 sequentially. The Arduino lights up segments in sequence to show numbers from 0 to 9 one after another. This demonstrates how programming and timing can make the display count automatically. In this lesson, we faced challenges while working with a 7-segment display. Making the numbers appear correctly required careful wiring and coding, and ensuring that the digits change smoothly demanded proper timing and logic in program. These challenges help us understand how to control each segment using Arduino. Next, we'll try some fun tasks to apply what we learned. These activities will let us experiment and test our skills with Arduino. Task 1. Dancing lights. LEDs light up in a sequence, creating a dancing effect. This demonstrates timing, sequencing, and basic circuit control. Task 2. Traffic light simulation. LEDs are programmed to mimic a traffic light. This shows real-life application of Arduino in controlling multiple outputs in sequence. Task 3. Custom Melody Challenge. The buzzer plays a melody programmed by the user. This teaches tone control, timing, and creativity in coding. Task 4. Multi-message Morse code transmitter. The buzzer sends multiple messages in Morse code. This activity demonstrates how information can be transmitted using signals. For additional task, Buzz Lock 5. The buzzer sounds for 5 seconds when activated. This shows how to control output duration using code and timing. While working on all the tasks, we experienced several challenges that tested our patience and problem-solving skills. For the dancing lights and traffic light simulation, some LEDs didn't light up properly at first due to incorrect wiring or missing resistors. Timing the lights also required adjusting the delay values to make the sequence realistic. In the custom melody challenge, creating the right tone of rhythm was difficult because the buzzer pitch needed precise code adjustment to sound like an actual melody. For the multi-message Morse code transmitter, It was a challenge to match the correct timing for dots and dashes and make the buzzer respond properly to each message. Lastly, in bus-log task, the main issue was setting the exact 5-second duration and ensuring the buzzer turned off automatically after the delay. Despite these issues, we managed to troubleshoot and improve our circuit design successfully. Our journey in this robotics class has been fun and challenging experience. We learned how to use components like LEDs, buzzer, and displays to bring simple projects to life using Arduino. At first, we thought robotics was just about wiring and coding, but we realized it's also about patience, creativity, and teamwork. Our point of view has changed. We now see robotics not just as a subject, but as a skill that helps us think logically and solve real-world problems. We're looking forward to learning more complex projects in the future, like sensors, automation, and maybe even building a small robot that moves or responds to commands. And of course, our journey wouldn't be complete without a few funny moments, from wrong wirings, misplaced, jumper wires, and buzzing sounds that wouldn't stop.
And that's all for today's video mga Triobots.
Don't forget to like, share, and subscribe.
And hit the notification bell for more updates